we are going to talk about the combined equation of pair of lines which may not pass through the origin. And we have seen that whenever we find the combined equation of pair of lines which may not be intersecting at the origin, will be of this format. Let's say 2x plus y plus 1 into x plus y plus 3 equal to 0. Since the lines are not passing to origin, there will be a constant term present in the equation. When you expand this equation, you will be getting terms containing x square, xy, y square, x, y, and constant term. Therefore, I can say that any combined equation, any two lines combined equation will be ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This would be the format of the combined equation of any pair of lines. But there is one issue in this particular equation. Every equation of this kind may not represent a pair of lines. For example, if a is 1, b is 1 and h is 0, this equation would turn up to x squared plus y squared plus 2gx plus 2fy plus c equal to 0. And you are aware that this is the equation of a circle. That means this equation can also represent an equation of a circle. Suppose, let's take a as 1, h as 0 and b as 0. This would become, this equation would turn to h, a is 1, so x squared term will be there, h is 0, b is 0, you will have 2gx, you will have 2fy plus c equal to 0. In other words, on the left hand side you can have y and right hand side you can have a quadratic equation of this kind. Hence, this would represent a parabola. Therefore, I can say that every equation of this kind need not represent a pair of lines. It can represent any curve in two-dimensional geometry. Now we will see that when will this equation will represent a pair of lines. This equation would represent a pair of lines if by shifting the origin, this equation can be converted to the form ax square plus 2hxy plus by square equal to 0. Geometrically, if this is representing a pair of lines of this format, if I shift the origin to the point of intersection, then it would become a pair of lines passing through origin. If I shift the origin to h comma k, which is done by substituting x by capital X plus h and substituting y by capital Y plus k. If shifting the origin to h comma k, this equation reduces to this format, then I can say that this particular equation represents a pair of lines. This theory is not important for the exam point of view, but I will just show you the theory so that it will be. Now we are going to derive the condition for this equation to represent a pair of lines. So as I told you before, let's assume the point of intersection as alpha comma beta. Alpha comma beta is the point of intersection of this equation if it represents a pair of line. So what I'm going to do is I'm going to shift the origin to alpha comma beta. When I shift the origin to alpha comma beta, I will change this equation to a new equation. The new equation is obtained by replacing small x by capital X plus alpha and small y by capital Y plus beta. So the new equation is obtained by a into x plus alpha square plus 2h into x plus alpha into y plus beta plus b into y plus beta the whole square plus 2g into x plus alpha plus 2f into y plus beta plus c equal to 0. Now I will change this equation into the form capital X square, xy, y square, x term, y term and constant term format. Now what I have done is I have replaced x by x plus alpha, y by y plus beta and written the equation. After that, I have taken the coefficient of a together. When you expand this, x plus x, a plus b the whole square. This is expanded, this is expanded, this is so expanded, and this is expanded. Then what I have done is, I have taken the, in order, x square term, xy term, y square term, x term, y term, and constant terms. Remember, x and xy are the variable. So alpha, all the term with alpha, beta, and c will be the constant term. Now this equation would represent a pair of lines only if the coefficient of x, coefficient of y, and constant term becomes 0. Then only it will become homogeneous equation. Then only it will represent a pair of line passing through the origin, because a new origin is nothing but alpha beta. We have shifted the origin to alpha beta. After shifting the origin to alpha beta, what has happened? After shifting the origin to alpha beta, this equation became an equation of a pair of lines passing through the new origin. Therefore, these terms should not be present in the equation. Hence, I get the condition. First condition, a alpha plus h beta plus g should be 0. This is my first condition. Second condition, h alpha plus b beta plus f should be equal to 0. And third condition, this whole expansion should be 0. So three conditions I will be getting, and I am going to show that this two condition can make this a much smaller condition. Hence, I am going to get three conditions in total. Now, what we are doing is, I have took the three conditions. First condition, a alpha plus h beta plus g equal to 0. Second condition, h alpha plus b beta plus f equal to 0. And third condition, a alpha square plus 2h alpha plus b beta plus square plus 2g alpha plus 2f beta plus c equal to 0. This is very easy to remember. It is nothing but just substituting alpha beta in the original equation. Now this third condition, I am going to reduce it. What I have done is, wherever 2 is there, I split it. H alpha plus beta, H alpha plus beta, G alpha, G alpha, F beta, F beta. So I have splitted them so that I can combine all the terms with alpha. First this term, and G alpha. These three terms are combined together to give you the first bracket. Next three terms are combined together, H alpha beta, B beta square, and F beta combined together. And remaining terms, that means this, and this. Now only three terms are remaining. These three terms are written here. Alpha is common here, beta is common here, and the last three terms. Already we have seen from the equation 1 that this is a 0. From equation 2, this is 0. So we have left with only one condition, plus c equal to 0. So my three condition reduces to, first one, a alpha plus h beta plus g equal to 0. Second condition, h alpha plus b beta plus f equal to 0. And last condition, g alpha plus f beta plus c equal to 0. So if these three conditions are satisfied, then only the equation would represent a pair of lines. So that means I should have a proper value for alpha beta in three equations. What are the three equations? Ax plus hy plus g equal to 0, hx plus by plus f equal to 0, gx plus fy plus c equal to 0. If these three equations have a common solution, then only the given equation would represent a pair of line. And we also know that the condition for three equation to be having a common solution, or three equation to be consistent, is that determinant should. By applying the condition for consistency, these three equations are consistent if the determinant of the equation is equal to 0. What is the determinant of the equation? A, H, G in order, H, B, F in order, G, F, C. So I can conclude like this. An equation of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 will represent a pair of lines if this equation can be reduced to the form ax square plus 2hxy plus by square plus is equal to 0. If I can reduce this equation to this format, then it would represent a pair of lines. This can be reduced to this format provided this determinant is equal to 0. So finally, what I can say is that this particular equation will represent a pair of lines if the determinant AHG, HBF, GFC equal to 0. It's easy way to remember. All happy girls having boy friends go for cinema. You can make a sentence like this and learn. Another way of learning is much easier method is take the alphabet of all X terms A, H, G in order. Take the alphabets of all the Y term H, B and F and take the last three alphabet, that's the third row. Once again, X terms are present in this three. All of them are what alphabets with them? A, H and G. That's your first row. After that, take the Y terms. Y is present in these three terms. What are the alphabets present with them? H, B and F. So that moves to the second row. And the third row is the last three linear terms G, F and C. Don't take two. We are taking only the alphabets. So that's another way of remembering. Now third method is you can remember the whole expansion itself. If you expand this determinant, you will be having A, B, C plus. Now remember, if you arrange these letters in the order of alphabetic order, first A, B, C, then comes D is not there, F, G and H. This is alphabetic order. So ABC product of the three number plus 2 times FGH, then AF square, BG square and CH square with the negative signs. Subtract. This will be the expansion of this determinant. ABC plus 2FGH minus AF square, BG square, CH square. They are all subtracted. If this equation is equal to 0, this statement, this condition is satisfied, then this equation would represent a pair of lines. So my final answer, this equation represents a pair of lines. Either this determinant is 0 or this statement is 0. You may use any one of the condition, whichever you feel more easy. If you use determinant, you can use determinant's property. If you use like this, you have to directly substitute the values. Now let's understand geometrically what does this whole theory means. This equation represents a pair of lines of this kind. Origin is over here, x-axis and y-axis. If this determinant becomes 0, then this equation will convert to this. When does this determinant become 0? When we shift the origin to alpha comma beta, the new x-axis and new y-axis is created and the origin became the old point alpha comma beta. Now this became a pair of lines passing through the origin. Therefore, this pair of lines equation would be the same A, same 2H, same B. In other words, if I have an equation 3x square plus 4xy minus 5y square plus 4x plus 6y plus 1 equal to 0. Imagine the determinant of this equation is 0. Then the new equation would be 3x square plus 4xy minus 5y square equal to 0. In other words, this both equation will have the same slope. This both equation will have the same angle. So to find out the slope of the line, we need to find the slope of this line. To find out the angle between this line, we need to find the angle between this line. So in summary, if this equation represents a pair of line, taking same coefficient A, H and B and create a homogeneous equation, this will represent a pair of line which is parallel to it. Therefore, to obtain the slope of this line, it is sufficient to obtain the slope of this line. Derive the auxiliary equation, solve for m, you will get the slope of this two line. To find the angle between these two lines, you can find the angle between these two lines. Now let's come to the conclusion. This is a non-homogeneous equation. This non-homogeneous equation, by shifting of the origin, we can convert it into a homogeneous equation if this equation represents a pair of lines. And for the condition for this equation to represent a pair of lines is determinant A, H, G, H, B, F, G, F, C. This determinant should be 0. This is a condition for this equation to represent a pair of line. If you want to write the expansion of this directly, A, B, C plus 2FGH minus AF square minus BG square minus CH square equal to 0. Either use this or use this. Second point to remember is, how do you come to know the slope of this line? The slope of this line is given by the root of the auxiliary equation bm square plus 2hm plus a equal to 0. Solve this equation. You will get two values for m, and they will be the slope of this pair of lines. That is, the root of the auxiliary equation will be the slope of the lines represented by the combined equation. Second, if I want to find angle between these two lines, tan theta is equal to modulus of 2 root h square minus ab upon a plus b. So we have one more conclusion. If a plus b is 0, the lines will be perpendicular. If h square minus ab equal to 0, the lines will be parallel or coincident. Lastly, if I want to find out where do these two lines intersect, I want to find out what is alpha and beta. There are two ways to do it. One is solve the two equations which we had done before, ax plus hy plus g equal to 0, hx plus by plus f equal to 0. Solve these two equations simultaneously, and when you solve these two equations, you will get the x coordinate and y coordinate. So the point of intersection can be written as this is the formula to calculate the point of intersection. It may be a little difficult to remember this formula, so it is easy to remember. Just create two linear equations with the same order, ax plus hy plus g equal to 0, hx plus by plus f equal to 0, and solve both the equations simultaneously. You will get the point of intersection as bg minus hf upon h square minus ab and af minus gh upon h square minus ab as the point of their intersection. So three formulas total. Condition for the lines, this equation to represent a pair of line. How to find the slope of the line by solving the auxiliary equation. How to find the angle between the lines by using tan theta is 2 root x square minus ab upon a plus b. Then how to find the point of intersection of the lines by solving two linear equations, ax plus hy plus g equal to 0, hx plus by plus f equal to 0. And if you solve, you will get the point of intersection as this. So if you can by have this point of intersection, well and good. Otherwise, this is very easy to learn.